Hello everyone. It's been so long. It's been years. I have not made any video and I have not posted anything. But today I promise I'll be frequent to post videos. So recently I made three thesis projects. So I will start from the third one and I will give you a complete explanation and tell you what is this about and how we can use it. Okay, so the third one is YOLOv8 real-time object detection. So before going further, let's just start what is object detection first. So this is basically a computer vision technique that not only classifies objects in an image, but also locates them by drawing bounding boxes. Like for example, in real time, you can see nowadays it detects persons in CCTV footage. It detects vehicles also on roads. It detects animals, detects products on the shelves, and so on. So unlike image classification, which only says this is a dog, object detection says there is a dog at these coordinates, x1, y1, x2, and y2. So now we understood what is object detection. Now let's understand what is YOLO. So YOLO basically it is not you only live once, it is you only look once. So it is a family of deep learning models known for real time speed, high accuracy, lightweight deployment, and one pass detection. That is the fastest among detection models. So YOLO V8 basically released by Ultralytics in 2023. It is the latest and best performing version. It has different sizes: nano, that is the fastest, V8N, and then the smallest, medium, and largest. YOLO V8X is the extra large that is used for best accuracy. So for this project, I am using YOLO V8N because it trains faster on Google Colab. That means nano I'm using. So the goal of this thesis is to train a YOLO V8 model on a small data set, that is COCO 128, evaluate the accuracy, MAP score, and perform real-time prediction. We will export this model also for deployment. So this basically demonstrates the complete deep learning pipeline of training, testing, inference, and deployments. The dataset we are using is COCO 128. So COCO 128 is a small subset of the Microsoft COCO dataset containing 128 annotated images. Each image has labels like person, dog, car, cat, airplane, etc. So why we are using COCO 128? Because it is light and faster to train. It is good for demos, includes bounding boxes and notations, and it automatically downloaded by Ultralytics. So now you don't need to manually upload anything, you know. So how the YOLO V8 works internally? It follows three-step pipelines. One is the backbone. It extracts deep image features using convolution layers, like for example detecting edges, texture, shapes. And the second step is its neck. It combining features from different scales to detect small, medium, and large objects. The third step is the head. It predicts bounding boxes coordinates, object class, confidence score. So this is why ULOV8 is the accurate and multi-scale detection. So now you can see that we are installing, it has been installed by the Ultralytics library. So we are installing that library from pip. You can see here. So from Ultralytics we are importing YOLO. You can see that we are succeeded by that. I've already this thing takes time to run, so I've already run this thing, and will show you the output. This thing I put it on train again because I wanted to show you some of the images. So this is why, so that the my drive will be mounted by this data set. I run this section again. So now you can see here we are doing the training on Coco 128 demo. So what this training process include, let me tell you. It basically downloads the data set, it loads training and validation images, it learns the object patterns, it adjusts the weights using back propagation, and then it shows training metrics like box laws, classification laws, mask laws. Here you can see that. You Let me just make you Let me just explain you what is this. It basically adjusts weights using backpropagation, and then it shows the training matrices like box laws, classification laws, mask laws. If segmentation is there, then MAP score. These are the accuracy matrices. Then now it is for training for 30 epochs. It will take 5 to 10 minutes, because we are on collab GPU. We are using collab GPU, and then we are running the inference. Then we are running the inference. That means prediction. After training, we have tested the model on the images. So now, if you will see the output, you can see the output. The output basically includes images with bounding boxes, the class name, confidence score, and the color coded annotations. You can see that it is saying, like, this image has one cat. The another image has one dog. The another image is having one spoon, one ball, 11 carrots, and so on and so on. Let me just show you. Let's just one image. Let's say this image. Okay, this image is detecting two giraffes. So now let me open this image. Last is 25.jp jpg. You can see two giraffes here. One is here and one is here. So yeah, it was like difficult to see this giraffe, in this image here. But now you can see the accuracy of this model basically detects it, and it is saying, like, here it is. Now let's just see the another. Let's just test another image also. The another is last is coming 30.jpg, and here it is. Let's just open this image and see what our model is saying. Model is saying there is a one potted plant, one vase. So yeah, we have opened this image, and see, model is correct. There is a plant here and there is a vase. Yeah, so we can say that this model is so good. The accuracy is so good. So basically this was the whole concept about. So why is this project important today? Because it is using in everywhere. It is used in autonomous vehicles, it is using in CCTV surveillance, it is using in retail store analytics, used in robotics, used in agriculture also for detecting crops or pests. Nowadays it is using in healthcare also to detect tools or tumors. It is used in industrial defect detection also. So it is a state of the art and widely adopted in the industries. So this was the whole concept about. I hope you like this concept, you like this topic. Thank you for watching.